Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have an equation and we have to find dy dx from this equation implicitly. So note that first of all, this is an implicit equation because it is not written as a function in an explicit form. It's not written as y equals something in terms of just x so that you can just evaluate dy dx directly. This is an implicit equation and we have to evaluate dy dx from this equation. So what we do is we apply dy dx to both sides of the equation, or d dx. So we apply d dx to both sides. So we have d dx of x square minus 3 natural log of y plus y square on the left, and we will have d dx of 10 on the right. And then we try to take the derivative of each term separately. Now notice that this right hand derivative should be easy to compute. Let's compute that first. 10 is just a constant, so the derivative is 0 because the derivative of any constant is 0. But on the left hand side, we have three separate expressions. So let's first split this entire derivative into three separate derivatives. So we will have the derivative of x square minus derivative of 3 ln y and plus derivative of y square. And we have to evaluate each one separately. So let's start with the first one. What is the derivative of x square? Now you have to be very careful about the fact that we are taking d dx. So this is the derivative with respect to the variable x. And the function that we have is also x square. Since they are the same variable, you can just apply the rule of derivative, and in this case is the power rule, to say that this derivative is just 2x. That's fine. For the next term, notice, first of all, this constant 3 can be pulled out, so that's not a problem at all. But then you will have d dx of natural log of y. Now notice the difference here. Here you're taking derivative of x, but the function doesn't have x there. It has a different variable. It has y, and y is a function of x. So you have to be very careful when you are taking derivative of this type of expression. So please notice, here you have x and here you have y. So how do you evaluate that derivative? Please recall that when you have a situation like that, say you have to evaluate d dx of natural log of not x, but say a different expression u. Then what do? We use chain rule. So chain rule says first you consider the outside function natural log, and the derivative is 1 over whatever expression is there, so 1 over u. But then you can't stop there. You have to also multiply it with the derivative of u. So you have to have du dx. Now in this case, consider this y is like a u. Okay? So how do we evaluate that derivative then? Okay, so we will have this 3 and d dx of ln of u. So first we have to have 1 over whatever is there, so 1 over y, but then you can't stop there. You have to have d dx of that u. In this case, u is y, so you will have to multiply with dy dx as well. Okay, now the first part remains 2x and this negative remains here. We haven't talked about the third expression yet. So let's consider this third expression one more time. This is d dx of y square. And notice the same thing happening again, right? We have to evaluate derivative with respect to x, but we have a different variable y. So again, you have to be careful. You can't just apply the power rule, but it's a chain rule. So first, consider the power rule. So it's something to the power 2, and the power rule is 2 times that something, in this case is y. But then you can't stop there. You have to take the derivative of that variable as well. So this should be multiplied with d dx of the y as well, which is dy dx. And that entire thing will be equal to 0. Now we have taken the derivative of each expression in this equation. Okay, remember our question? We have to find dy dx. We have to evaluate dy dx. So how do we do that? Well, we will have to extract dy dx from everything else. And then in the end, we have to have the equation dy dx equals something. So in order to do that, first we combine the terms that has dy dx together on the left hand side. And the term that doesn't have dy dx, we move it to the right side. So these two terms have dy dx. So let's combine it. Notice that in both terms we have common factor dy dx. So you pull it out and you'll be left with, from first term is negative 3 over y. From the second term, plus 2y. That's how you combine those two terms. And then this 2x, you can move it to the right hand side as negative 2x. And now how do we evaluate dy dx? So you just get rid of this expression that is attached to it by dividing both sides by that expression. And so dy dx will be equal to, right hand side we have negative 2x, and then you divide by this entire expression, negative 3 over y plus 2y. And notice that we have an expression for dy dx in terms of x and y. And that is dy dx that we have evaluated implicitly from the given equation. Thank you.